Alright, we're starting at number 12 on the chapter review. Remember, the domain is what x can equal to make sure that f of x is going to be a real number. That means that this underneath here cannot be what? Can't be negative. So that means that 2x minus 7 must be greater than or equal to 0. It can be equal to because square root of 0 is 0. That is a real number. Anything less than that, you would have a root of a negative number. Not real. Haven't really talked about imaginary numbers yet, but we will. So if 2x minus 7 is greater than or equal to 0, then 2x must be greater than or equal to 7. If we add that 7 to both sides, divide both sides by 2, x is greater than or equal to 7 over 2. How do we write this? Well, we can write it as set builder notation, which would look like this, or we could write it as, because it is greater than or equal to 7 over 2, then we'll say it is equal to 7 over 2, or anything more than that, infinity with a parentheses. That's number 12. 13, simplify. Assume that each variable can represent any real number. So that means that 25 t squared, well, root of 25 is 5, root of t squared is t, and what do we have to do? Because we are assuming that this is a real number, and any radical must be what? Positive. Positive, so how do we ensure that it's positive? Absolute values around that 5t. Or similarly, you can just have 5 absolute value of t. Both answers are acceptable. 14, if you have a root of anything squared, well, we can just treat this as something squared. Doesn't matter what's inside, even if it's a plus, as long as it's the whole thing squared. The square root of anything squared is itself. So this is c plus 8. You have a variable in there, have to make sure that it is positive, so absolute value goes around the whole thing, not just around the c. 15, you got your root of x squared minus 6x plus 9. Do not take the root individually of the x squared, the 6x, and the 9. You need to do what first? Well, we should probably factor, because I cannot take the square root of these individually. This will not be x minus the square root of 6 plus 3. Factoring gives me x minus 3 squared. Square root of anything squared is itself. Again, have a variable, so needs to be in absolute values. Number 16, same thing. You just need to factor first. So if we start out 4x squared plus 4x plus 1, factor 2x plus 1 squared. You can use bottoms up. I'm going to skip that step right now, but you should know that it does factor to 2x plus 1, and root of anything squared is itself. Absolute values. 17. The fifth root of negative 32. Remember that any odd roots are allowed to have negative radicands inside. But if it's even, this would be undefined. Odd, let's split this up right now, is a negative 1. Factor this out. The 32 is 2 times 2 times 2 times 2 times 2. Just to show you, if you do a factor tree on 2, 3, 4, 5 2's and a negative 1. The fifth root of negative 1, because you have negative 1 times negative 1 is positive, times another negative 1 is negative, so on, so on. Just pull out a negative. Odd root, negative inside, pull out one negative. Fifth root of 2 to the fifth is itself. Don't need absolute values because we are doing an odd root. Number 18, negative, pull that negative straight out. Be the same thing as cube root of the top over cube root of the bottom. Cube root of the top, cube root of 64 is 4. Cube root of x to the sixth, remember that 3 goes into 6 twice, so that leaves your base squared, no remainder, nothing left underneath the radical. Cube root of 27 is 3. 19. Fourth root, x to the 12th, y to the 8th. Because it is a fourth root, Then we're going to say 4 goes into 12 3 times, so this is x cubed. 4 goes into 8 twice, so you have y squared. No remainders, this is your answer, but because it's even, let's put those in absolute values. Always remember your absolute values if it says that the variable can represent any real number, and if it's even. If it's odd, like we had in number 18, the negative is just going to stay outside. Do not need absolute values if you have an odd index. Number 20, we're taking the 6th root of 64x to the 12th. 64 is going to factor 32 and 2, 16 and 2, 4 and 4, 2, 2, 2, 2. So that's 2 to the 1, 2, 3, 4, 5, 6. This is the same thing as 2 to the 6th, x to the 12th. Take your index. 6 goes into 6 once, so with no remainders, so nothing is left underneath the radical for the 2. 6 goes into 12 evenly as well. It goes into 12 twice, and nothing is left in the radicand. In this case, 2 is already positive, x squared, because anything squared is positive. You don't need the absolute values. If you put the absolute values in there to be safe, that's fine. Number 21, an equivalent expression using the exponential notation. Right now we are in radical notation. This whole thing is to the 4th. What this is going to tell you, do the inside first. Start with your base, 5ab. The entire thing is to a cube root. That means it is to a 1/3. And that is to the 4th. What do you do with exponents when you have something to a power to another power? Well, these two get multiplied together. So this is just 5ab to the 4/3. And you can leave it like that. 22, they're going to say the opposite. I want to take this exponential notation and write it as radical notation. First, let's multiply here to simplify. So we're going to say we have 16 to the 3/4. 6 times 3 is 18 over 4. Simplified version of that is, since they're both divisible by 2, is 9 over 2. Now 16 to the 3/4. The 4 tells you what? 4th root of 16 to the 3rd. And this is square root of a to the 9th. Reason that I did this first without cubing it. I don't want to cube 16. That's going to make a very large number. But I know the 4th root of 16 is 2. So that just leaves me with 2 cubed. 2nd root of a to the 9th. Well, 2 goes into 9 how many times? Goes in there 4 times with a remainder of 1. So you just have a to the 1 underneath your root. 2 cubed is 8. A to the 4th radical a. Final answer there. 23, because this is square root. 2 goes into 6 3 times. 2 goes into 10 5 times. No remainders. 24. 6th root of x squared y squared. Using rational exponents, this is going to tell us that we have the x squared y to the 1/6 all to the 2nd. 2 times 1/6 is 1/3. 2/6 is the same thing as 1/3, and 1/3 is just the cube root of x squared y. 2/3, negative 2/3, 3/5. What happens? 3 and the 3 will cancel because you multiply. So you just have x to the negative 2 over 5. What does that negative tell you? Negative tells you that you want the reciprocal of this. So we have x. The 5 tells you the 5th root, and the 2 tells you power. Negative again, reciprocal. Denominator is the index, so your root. 2 is your exponent. What do we do when we divide things with the same base? This is the same thing as 7 to the negative 1/3 minus a negative 1/2 because we are dividing it. So we're going to subtract our exponents. This is 7 to the negative 1/3 plus 1/2, which once you get common denominators, this is negative 2/3 plus 2/6 plus 3/6, which is 7 to the 1/6, which equals the 6th root of 7 squared. They want to find the simplified form for this. So what does that mean? Well, it's kind of what we were doing in the earlier sections, where we have a square root of each one of these things that are multiplied together. That is the same thing as taking the square root of each of these separately. Square root of 25 is 5, positive. And square root of this is x minus 6. Rather than putting parentheses around it, I need to make sure that it's absolute value, and absolute value signs do account for parentheses. So you don't need additional parentheses. For the sake of time, I'm just going to show you number 28 and 29. We'll move directly to number 30. Putting that all together, well, I have 24, 18. If you don't want to multiply these things together, 1, I see a negative out here. I can take that out right away. Just to remind myself, I can take out that negative. 24 and 18. Well, let's factor that. 24 is the same thing as 6 and 4, 3 and 2, 2 and 2. 18 is the same thing as 2 and 9, which is 3 and 3. So how many 2's do I have? I have 4 2's. That's 2 to the 4th. I have 1, 2, 3 3's. That's 3 cubed. With my x's, x to the 10th and x to the 7th, add those together to get 17. That's what you do when you multiply exponents. This makes y to the 12th. 8 plus 4 is 12. Since you have a cube root, cube 3 goes into 4 once, so a single 2 is going to come out. 3 goes into 3 one time, so one of those is going to come out. Let's do our remainders first. This was a remainder of 1, so I have a 2. I don't have a remainder here, so that is nothing. 3 is going to go into 17 5 times. That means 5 x's come out with a remainder of 2. X squared gets left inside. Y to the 12th, 3 goes into 12 4 times with no remainders. So that is my final answer for number 30. Well, almost. 2 times 3, 6. X to the 5th, y to the 4th, cube root 2x squared. Number 31. It's probably easiest to try and simplify these first by putting them all under a common radical. What's going to simplify? Well, I have an x on top, x on bottom, treated as a fraction. Those both simplify to 1. A 6 and a 10 will simplify. This simplifies to a 1. This simplifies to a 6. So now I just have the cube root of 6y cubed. Everything else is canceled. Cube root of 6, can't do anything with that, but I can do a cube root of y cubed, and that's just a single y, cube root of 6. Well, I still have my 1/2. I'm going to keep that separate. Put all of this under the same radical, so 75x over 3. 75 divided by 3 simplifies to 25. So this is 1/2, and since this is 1, I no longer need that 1 under the denominator, is root 25x. The root of this is 5. 1/2 times 5 root x, and I can just simply put that all over 2. Last one, number 33. 4th root of 48a to the 11th, c to the 8th. 4th root. So I got to see if my 48 is going to simplify to anything. Well, 48 is the same thing as 24 and 2, 12 and 2, 3 and 4, 2 and 2. So what does that give me? 1, 2, 3, 4. On top, I have 4th root, so I'm going to split these up. 4th root, c to the 8th. I have 4 2's, so this is 2 to the 4th, times 3 times a to the 11th. The 4th root of 2 to the 4th is 2. You got 3 left inside. Nothing's going to simplify there. A to the 11th, 4 goes into 11 twice with a remainder of 3. Fourth root of c to the 8th, 4 goes into there twice. So you just have c squared. Nothing else that I can simplify. That is my final answer.